Today I want to discuss about demultiplexers. Demultiplexers. So what is demultiplexers? This is the opposite operation of the multiplexers. Okay. In previous class, we discussed about multiplexers. So the four inputs or number of inputs is equals to one single output in multiplexers. But in demultiplexers, only single input and n minus 1 output. Okay, single input and n minus 1 outputs. So in this demultiplexer, this is also called data distribution. Okay, why we call it data distribution? So one single input is a distributed number of outputs. Okay, so next one is, it is also a combinational circuit. So here n equals to 2 power n relationship. So here n equals to 1 and here n is the output and 2 is the select lines. Okay, so here m equals to how to calculate the select lines. So by using this formula we calculate the select lines like this. So m equals to log to the base log base 2 power n. Okay, so m equals to log base 2 power n. So here the logic the block diagram of the demultiplexer is demux. This is the one input. Okay, this input is, this is the data selector, this is the data selector point. Data selector point, and here this is the outputs. Okay, y0, y1, y2, y3 and up to so on yn minus 1. Okay, so this is the block diagram of this is the input, and here also enable. Okay, when the enable is 0, then it is a active low condition, then the device does not operate. The device is off condition. If the enable is 1, the device is active high performance, and the device is on condition. Okay, so in this multiplexer, the different types of the multiplexers are there. So here 1:2, 1:4, 1:8, 1:16 and 1:32, like this. These are the different types of the demultiplexers. In multiplexers 2:1, 2:2, 2:3, like this. But here 1:2, 1:4, 1:5. 1:2 means one input and two outputs, one input and four outputs, one input and eight outputs. And here the selecting lines are calculated in this 1:2 demultiplexer. The selecting line is 1, and here the selecting line is 2, and here the selecting line is 3, and here the selecting line is 4, and here the selecting line is 5, by using this formula. Okay, so first of all we want to know about 1:2 demultiplexer. Okay, so the 1:2 demultiplexer is, so 1:2 demux. or demultiplexer, whatever it may be. So here this is the 1:2 demux, 1:2 demux, and here single input, and this is the enable, and here dual output y0 and y1. Okay, so these are the outputs and these are the input. Okay, now so n equals to, the relation is the n equals to 2 power m. Okay, so we want to calculate the selecting lines. So here this is the selecting line and this is the output. So output is 2 equals to, the selecting line is 2 power m. So here the bases are equal, then 2 power 1 equals to 2 power m, and then m equals to 1. This is the one type of the calculation, or in previous m equals to log base 2 power n. Okay, so here m equals to log, here the n is the outputs, so the outputs is 2 and 2. Okay, so log base 2 power 2 equals to 1. So here m equals to 1. So we want to calculate like this and like this, whatever it may be. This is the simple process. Okay, so here this is, so this is the one of the selecting line. Okay, so so now we draw truth table. Truth table. Okay, so the truth table, the inputs is enable and enable, S0 and y0 and y1. These two are enable and S0 is the, this is the selecting line. Enable and S0 is the inputs and y0 and y1 is the outputs. So the enable is 0, then the circuit is completely in off condition, then S0 0, y0 0 and y1 0. Then the enable is 0, then the S1 equals to 1. If the selecting line take 1 but the enable is 0, then the output is also 0. Then enable is 1, then the selecting line is 0, then the I naught, 0 means I naught. So here the output is enable here. So this is the 0. And 1, enable is 1, the selecting line is also 1. Then here the output is shifted to 1. Okay. So this is the truth table of the 2 into 1. Sorry, selecting. This is the truth table of the 1:2 demultiplexer. So we want to find the equation. So y naught will be equation of the output. So y naught is equals to, so here the output is enabled and here what is the inputs are 1, enable 1 and here 0. So that is E and S0 bar and I. So and y1, so y1 equals to E S0 and 1. So y1. So here the output is enabled here. So 1 1 1 1 means E and S0 and this is into I. So we can draw the logic design of the 1:2 demultiplexer by using these two equations. So here enabled E, S0 and I. Okay. So S, this is the complement of S0 and this is I. Okay. Okay. So E, S0 bar I. E, S0 bar and I. This is Y0 and Y1. Y1 means E E, S naught and Y. So this is the Y1. Okay. This is the logic circuit design. This is the logic circuit design of the 1:2 demultiplex. Okay. So the next one. So the next demultiplexer is 1:8 demux. Okay, so 1:8 means so 1 input and 8 outputs. Okay, 1 input and here also enable. So here this is the data selector and here 1:8 demux. And here 1, 2, 3, 4, 5, 6, 7, 8. Okay, these are the y0, y1, y2, y3, y4, y5, y6 and y7. So these are the output lines, and here we want to find selecting lines by using the input and output. So n equals to 2 power m. Here n means output lines means 8 equals to 2 power m. Here 2 cube equals to 2 power m. Then here the bases are equal, then the powers are also equal, so m equals to 3. So we want to draw the 3 selecting lines. Okay, so these are the 3 selecting lines, S2, S1 and S0. So we want to draw the truth table. So we want to draw the truth table here. So E, S0, S1, S2. Okay, these are the inputs. Okay, so next Y0, Y1, Y2, Y3, Y4, Y5, Y6 and Y7. Okay, so here the enable is 0, then the selecting lines is like this, and here 0 0 0 0 0 0 0 0. Why? Because here the outputs is all or outputs is 0. Why? Because here the enable is 0, so the device is off condition. Okay, so the device is 1, then 0 0 0. So this is the 0 0 0 means in binary code. This is the binary code of 0. So here I, then remaining or 0. Only y0 is enabled. So remaining or 0. And here enable 0 0 0 1. and here 0. So 0, 0, 1 means, so the output is shifted to y1. So then like this. Okay. So 1 0 1 0 0 0 and so 1 0 1 1. One. Fourth. So here the I4 is Y4 is enabled, so remaining is 0. Then here the Y5, so the output is shifted to Y5, and here 1 1 1 0. So 6 Y6 is enabled. So Y6 and 7 Y7 is enable here. So this is the truth table of the 1:8 demons. Okay. So once again I explain. So enable 0, then S0, S1, S2 is does not exist, and here the output is completely all 0. And next the enable is 1, then say the selecting lines 0 0 0. So we can that it takes 0 0 0, then the y0 is enabled, then remaining is 0. Then S1, then S0, S1, S2. So 0 0 1, 0 0 1 means 1. So the y1 is 1, then remaining is 0. Then 2, y2 is 2, then remaining 0. Then 3, y2 is 3, y3 is 3, then remaining 0. So like this. Okay, this is the truth table of the 1:8 D mux. Okay.